Educational Module Machine Learning. Learning Unit Core. Categories of learning. The input data contain a collection of features as well as labels. The mapping of features to labels is where the knowledge is encoded. Then the model will map new samples into their correct labels. Data, labeled, the training data have a label/class assigned to each input instance. For example, if the task was to determine whether an image contained a certain object, the data for a supervised learning algorithm would include images with and without that object, and each image would have a label designating whether it contained the object. Classification and regression algorithms are part of supervised learning. In both types of prediction of an instance's class is performed. Classification algorithms are used when the output class's values are restricted to a limited set of values, while regression algorithms are used when they are continuous real values. Regressors are also called function estimators and aim to capture the general trend on the data, since the data points are going to be very noisy in most tasks. The input data do not necessarily contain labels or target values. The models extract meaningful representations from the data itself. Data is unlabeled. The training data does not have a label/class assigned to each input instance. An unsupervised learning algorithm builds a model of a set of data which contains only inputs and no desired outputs. The goal is to find structure in the data. The most common process in unsupervised learning is clustering the data, cluster analysis. Unsupervised learning is also used on the data mining field, where the task is the discovery of previously unknown knowledge. Contrary to traditional machine learning, which focuses on prediction based on known properties learned from the data, data mining focuses on the discovery of previously unknown properties in the data, which are often quite large. This can be done by extracting information with intelligent methods from a dataset and utilizing techniques from other fields. Data mining uses many machine learning methods. Official definition: data mining, also called knowledge discovery in databases, KDD, is the field of discovering novel and potentially useful information from large amounts of data. Combination of the two previous approaches, with a portion of the training data missing the label/class. Data is both labeled and unlabeled. Reinforcement learning algorithms utilize feedback in an environment in the form of positive or negative reinforcement. An agent interacts with an environment. This interaction provides feedback between the learning system and the interaction at any step in time. The agent modifies its behavior with the awareness of the states, actions taken, and rewards for every time step. The goal is to compose an optimization process in order to maximize the accumulated reward. Reinforcement learning is commonly used for training an artificial intelligence system to play a game against a human opponent. Active learning algorithms access the desired outputs, training labels, for a limited set of inputs based on a budget, and optimize the choice of inputs for which it will acquire training labels. Meta-learning algorithms learn their own inductive bias based on previous experience. Feature learning is the process of automatically discovering better representations of the training data for a classification task. It replaces manual feature engineering, which is showcased in detail in later pages. Examples of feature learning include principal component analysis and cluster analysis. Feature learning algorithms, also called representation learning algorithms, attempt to preserve the information in their input but also transform it in a way that makes it useful, often as a pre-processing step before performing classification or predictions. Feature learning algorithms allow reconstruction of the inputs coming from the unknown data generating distribution, while not being necessarily faithful to configurations that are implausible under that distribution. Overall, it allows a machine to learn features. Supervised feature learning, neural networks, perceptrons, and dictionary learning. Unsupervised feature learning, principal component analysis, autoencoders, and clustering. In the previous pages we assumed that all the training data is available before building the model. In many modern applications, data is available only in a streaming fashion. This task is tackled by online learning. Online machine learning is a method in which data becomes available in a sequential order and is used to update our best predictor for future data at each step, as opposed to batch learning techniques which generate the best predictor by learning on the entire training data set at once. Online learning proceeds in rounds. At each round a training example is revealed to the learning algorithm, which uses its current model to predict the label. The true label is then revealed to the learner, which incurs a loss and updates its model based on the feedback provided. The algorithm is depicted below. Association rule learning is a rule-based machine learning method for discovering relationships between variables in large databases. It is intended to identify strong rules discovered in databases using some measure of interestingness. The goal, assuming the set of data is large enough, is to mimic the human brain's feature extraction and abstract association capabilities for data that has not been categorized, similarly to most machine learning approaches. The main difference between a rule-based algorithm compared to other traditional machine learning approaches is that it attempts to identify and utilize a set of relational rules that collectively represent the knowledge, instead of identifying a singular model that can be universally applied to any instance. For example, a rule could be, if someone buys bread, peanut, and butter, then probably buys and meat. This would indicate that a customer that buys the first three products is more prone to also buy meat. In market basket analysis, we are interested in items frequently bought together. Support is an indication of how frequently the item set appears in the data set. Confidence is an indication of how often the rule has been found to be true. A very simplistic way to find association rules is to compute all the frequent items that exceed a given support and confidence threshold. A common algorithm to generate association rules is the a priori algorithm. The main positives are the following. It has easy parallelization and is simplistic. However, there are some negatives. It assumes that the entire set of data is accessible in memory. Also runs through the data multiple times, worst case, as many times as there are items.